Welcome. This is a chemistry lesson 7.01. We're starting a new packet, and this is on the names and formulas of chemical compounds. So I suppose I would add to this of compounds. So we've talked about ionic bonding, we've talked about covalent bonding, and but up to this point, everything we've done, we've dealt with elements. So from this point after, we're going to be dealing with compounds, and that'll be mostly ionic compounds, but we're going to deal with covalent compounds. We're going to kind of wrap up with those in this chapter. So this first page is review to go over some of the things we've already learned. And one of the key points that we've had is this octet rule. And that says that main group elements want 8 valence electrons. There are exceptions, of course, except if we look at hydrogen, helium, lithium, and beryllium, they only have an s orbital, so they're going to be 2, and boron is 6. So because we don't have enough orbitals yet to get up to the 8, but everything after boron wants 8 valence electrons. So they can do that 2 ways. So the way they can get these 8 valence electrons, one is through making forming an ion, where they give up or take, they give or take an electron. Or they can covalently bond. And if they covalent bond, they share electrons. So if you, there's some, well, we'll get to the new terms here in a second. So up here I have lithium again. And remember, lithium has 3 protons. So I've got a positive here, positive, and a positive. And each of these electrons in the orbitals have negative charges. So right now I have a positive 3 in my protons and I have a negative 3 in my electrons, but we've got, this is the 1s orbital, and this is the 2s orbital. If it gets rid of this, it has a full 1s. And so what it'll do is it'll kick that electron out. So over here I have 2 electrons. Well, if I have plus 3 protons and I have 2 electrons, that gives me a plus 1 charge. If I put this next to an element that has a negative charge, so let's say I put this next to chloride. Chloride has a minus 1 charge, so I've got a lithium plus 1. If I put this next to a chloride, which has a minus 1 charge, these two are going to be attracted to each other. And we'll get attraction, and they'll stick together because opposites attract. So an ionic bond, we call that an ionic bond. So it's actually the charges between the ions that cause ionic bonds to form. And then these guys will form that crystal lattice where they stack, they'll alternate a positive and negative, a positive and negative. And then on the next row, they'll alternate so that the positives are always around negatives and negatives are always around positives. One of the things that's going to be important that we've talked about are valence electrons. So if we talk about our valence electrons, remember those are in the main group, those are equal to the column number. So if you are counting main group columns, hydrogen is 1, beryllium is 2, boron is 3. If you want to know how many valence electrons carbon has, it's in the 4th column. So that's going to be 4 electrons. There's 2 terms I do want to introduce here, and that is oxidation and reduction. And I'm going to go ahead and switch, and I'm just going to write over here. Oxidation and reduction. And we're going to talk about these as we go through, especially into next chapter. So if you want to remember what oxidation and reduction is, you can remember oil rig. And that stands for oxidize Oxidize is lose. Reduce is gain. Well, what is it we're gaining or losing? We are gaining and losing electrons. So oxidation, oil rig, oxidize is lose electrons. Reduction, rig, reduce is gain. We're gaining electrons. And as long as you remember oil rig, you'll never forget oxidation and reduction. And if you go on and take collegiate chemistry, everything becomes about oxidation and reduction. So we introduce that here, and we'll deal with it again. We'll deal with it more later, especially in the next chapter. Let's go ahead and I think we're pretty short. I didn't set my timer. Let's go ahead and we're going to do the second page on this video as well. So what I have here is I have sodium, and sodium has, here's the 1s orbital, here's the 2s, which is full. I'm sorry, yeah, and then here is the, where are we at, 1s, no, that's the 2s, this is the 2p, I'm not sure where the 1s is at, and this is the 3s. And we have one electron in the 3s orbital. Over here I have chlorine. Oh, I see, they put the 1s and the 2s together. So this is the 1s. And then this is the 2s and the 2p. And then this is the 3s and the 3p. So they put them together. So what we're seeing with chlorine, this is chlorine, this is sodium. I've got 1, 2, 3, 4, 5, 6, 7. So that way we can see all the valence. I have 7 valence electrons for chlorine, and for sodium I have 1. So what happens is sodium gives up this electron to chlorine, and I end up with sodium +1 and chloride -1. And just like we said on the last screen, those two are attracted by their charge. So this is a sodium ion and a chloride ion in an ionic bond. So remember, ionic bond is attraction via opposite charges. Anions are negative ions, and cations are positive ions. Get it? Because cat and pause. So we have cations are positive, anions are negative. When we write compounds, so when we're writing the names of compounds, the cation always comes first, and the anion always comes second. CCOND in a compound name. All right, let's also add a covalent bond here. So covalent bond. So here we said we have attraction via opposite charges. A covalent bond is sharing electrons. And the other thing is we said covalent bonds is between 2 or more nonmetals. And an ionic bond is between a metal and 2 or more nonmetals. So let's look at some examples. All right, let's take CaO. Okay, the first thing we have to ask, is this ionic or is this covalent? Well, calcium is a metal, and oxygen is a nonmetal. So this is going to be an ionic compound. My cation is calcium, and my anion is the oxygen, which we're going to learn is called oxide. I have 2 atoms, and I have 1 anion and 1 cation. All right, how about aluminum chloride? Aluminum is a metal. Chloride is a nonmetal, so this is going to be ionic. I have a total of I have 3 chlorides and 1 aluminum, so I have 4 atoms. I have 1 cation, and I have 3 atoms of anion. Okay, let's do one more. How about CO2? What do you think this is? Carbon's a nonmetal, oxygen is a nonmetal. This is going to be a covalent compound, covalently bonded compound. And there are no anions or cations, because only ionic compounds have anions and cations. And we have a completely different rule for naming this than we do for naming these, which we'll talk about in subsequent videos. So our takeaways for this lesson was a lot of review. We talked about how ions form. So over here, these are both types of ions. And we went over the octet rule. So we're almost always going to be talking about main group elements from this point forward. For the most part. I guess we have some transition metals in that mix. We talked about the fact that cations are positive and they come first, so that's my cation, that's my cation. Anions are negative, they come second. The ionic bond is between the attraction between the positive and negatives. Covalent is sharing electrons. We also said that an ionic bond is 2 metal and 2 or more nonmetals, whereas a covalent is just not nonmetals. So carbon and oxygen are both nonmetals. That makes that covalent. All right, so that kind of gets us started. Make sure you have all these basics down before we jump into naming compounds.